Hi, everyone. Thank you today for coming to our talk at USF. We would like to welcome all of our online guests and those who have come in person now that we are back to being also having in-person events. Now, we would like to announce our big in-person event, which will be in March, the 12th to the 14th, which is DISCO 2023. It is a data science conference. Okay. That's next. Speaker. Okay, so for today, our speaker is Uday Marepalli. He is a senior product manager at Upwork. Prior to this, he did work at Glassdoor and SmartAsset, and he also holds a master's degree in management from Columbia University. His talk today will be on building and launching machine learning products.
Thanks, Victor. Am I audible? We have a few things going on with that. Cool. Thanks so much for having me here. Quite a bit of a turnaround for a Friday afternoon. Really honestly, it's showing up. I'll do a quick introduction in a minute, but today we really talk about machine learning products are conceptualized and built in technology companies. Because this is organized by the Data Institute, assuming that folks here are really proficient in machine learning, I want to kind of clearly state that this is talk with less do with technical details about building machine learning, but more around tactical details of how companies are incorporating machine learning in products today, and how product managers and data scientists partner or collaborate with machine learning products. So, quick note about me. I started working my career in venture capital, where we invested in technology startups. So I met a ton of founders, got really interested in the AI ML space. That led me to join a tech startup, which essentially created chips or workloads for AI. This is essentially down to the metal, and we're talking about semiconductor chips that can accelerate AI workloads. So this is strategy work there. Then went to Columbia to get my master's in management, mostly business courses, one machine learning course, somehow got past it. And then I joined Glassdoor, which is a talent marketplace, connecting job seekers to jobs and providing information about companies, including reviews, salaries, and interview-related information. I was a part of the machine learning product management team there, where me and my team built a few different machine learning tech products. I'm currently working at Upwork, which is a freelancer marketplace that helps clients across the world hire freelancers for any of the work that they have. We'll talk a bit more about both of these companies because I've got a couple of case studies working up. But at Upwork, I'm a part of the product innovation team, which essentially builds new products that can innovate and accelerate up our score growth. Again, we'll talk a lot about some of these companies and the specific works that we do there once we get to the case studies that I have today. So, quick overview of the agenda. We'll chat about a bit about what product managers do at tech companies, what is the role, and type of product management roles out there. And then we'll segue a bit into how do tech companies think about building machine learning products. And I'll give you a framework in terms of how you can think about building machine learning products, either if you're in product management or data science. And we'll see this framework in action by talking about two examples, one from Upwork and one from Glassdoor, where we'll walk through some of the machine learning products that me and my team build in companies. Finally, I do want to talk a bit about some of the best practices that I have observed over the course of my career as to how product managers and data scientists can collaborate together. So hoping to give some tips and advice to the audience here. And then we'll do a Q&A towards the end. We can keep the session interactive too, so if you have any questions that you have or you want me to explain or elaborate on something, let me know and I'm happy to pause and take your questions. As an outcome of this talk, if you're interested in product management as a career, or you're interested in data science as a career, and are thinking about how do you think about business outcomes as a data scientist once you go to the industry, or if you're a new graduate student thinking about a career in either product management or data science, I'm hopeful that this stuff will be useful to you. Because a lot of these concepts and frameworks that we're going to be discussed today are stuff on how the industry operates. And there's a high chance that these are the kind of questions that you will get to as you go into interview at some of these companies. Does it sound good? Cool. I hope I managed to keep your attention on the Sunday afternoon after lunch. So feel free to kind of interrupt into that rate if there is a warning to those. So let's start a bit with what do product managers do at tech companies. And this is a pretty good graphic that I pulled out from the internet. It essentially talks about the role of the product manager being at the intersection of user experience, technology, and business. That usually means that a product manager is skilled or somewhat skilled in each of these areas. And the way that I would think about it or always thought about it is PMs are responsible to build products that are desirable by the users in a way that's technical, feasible, and viable for the business. So desirability, feasibility, and viability are the three corners of the role. And they do this not by themselves, but by collaborating with cross-functional teams, including engineering, design, marketing, and sales, and ultimately define the product strategy, the roadmaps, and plans to execute on that roadmap. It's a highly cross-functional role that involves working with multiple stakeholders across the company. And in some of these products, data science teams are a key stakeholder too. And I do talk about products and features broadly, but to make it a bit more real, any technology product that you use is a fair game. In terms of features, like you think about different features that Shopify has, or TikTok Reels, that's another example of feature. Today, we're using Zoom to share this link to participants who are participating virtually. So the share feature on Zoom could be an example of a feature. So I use the word product and features interchangeably in the conversation, but in your mind, like when you think about it, think about any software that you use or interact with, and that's out in the world there. Could be in the form of an app, could be in the form of a desktop software, could be in the form of like a game that we use, any software is fair game. So we spoke about PMs operating at the intersection of UX, tech, and business, but are PMs proficient in all of them equivalently? I think the answer is it depends. A lot of it comes down to companies and roles that people are a part of, but one distinction could be the kind of products that they work on. This is a visual that represents different kinds of product management roles in the industry, but to double click on some of them, if you're working as a new venture PM, you're essentially building a business strategy or product from ground up. So among UX, tech, and business, you need to index higher on business skills in order to be able to think about what are the business use cases and what's the strategy that you want to be pursuing. And then if you take platform PMs typically work on high-level, system-level stuff. So systems, databases, APIs. They usually tend to index a lot on technical skills because they're essentially working with a lot of stakeholders. Now, an interesting mix here is a domain knowledge PM. And PMs working in AI/ML mostly fall under the domain knowledge PMs today. All it really means is that they have a high-level understanding of how the domain works. In this case, how machine learning works. They're able to socialize it with different stakeholders across the company. And what that really means is you're able to work with data science teams like at a Scrum level or at a 10,000 feet view level. We are talking about like, hey, how do we approach this problem using ML? What are the models that we're using? Like, how are we measuring these criteria? But then you can zoom out to the 30,000 view and really talk to business stakeholders. And hey, here's what the team is doing, and here's how we're thinking about this problem. And here's what's machine learning doing, and here's what's going behind the hood. So essentially, like domain expertise PMs have a good understanding of the domain, can communicate about that domain to business audience and also technical audience. And in my experience, I've generally seen they have less of user experience related skills, but again, that's not a hard and fast. This is a general framework to think through the kind of product roles out there. But I also want to call out that a lot of this is company or industry specific. One other point that I want to make is we spoke about PMs working on ML related products to be like domain knowledge PMs. But I do see some of that changing. I think there's a couple of reasons. One of it is all the innovations that are happening in the generative AI space that I believe all of the folks here are in the know about. So essentially, it's in a funny instance, like most tech companies today define their like yearly roadmaps in Q4, which means like between the October to December period. And what ended up happening is OpenAI released ChatGPT end of November. And it's kind of funny that most of like the companies that I've been at are like friends working at different companies. They've taken what was their plan from Jan to June, which is like ideally the H1 roadmap. They've thrown it out, and now they're starting to think about how do we use generative AI in all of the products that we have. So advances in AI are kind of changing ways about how we think about product management and how we think about incorporating AI and ML into our products. And the second thing is there's so much change in consumer experiences too. Every one of us here love the apps that we use. We love Spotify for the recommendations that it shows us. We love TikTok for the personalized content it sees us. So across the board, consumers or users of products are preferring more customized or personalized experiences. And ML is a huge component of driving it. So what I kind of see happening here is most of the products or most of the PMs, depending on whichever products that you work, people will start to think about, hey, how do we incorporate AI or machine learning into the products that we have? And I think this is also critical to most data science enthusiasts because the opportunity has really opened up in terms of what you could be working on. If you want to be a data scientist, building some of these models, partnering with companies, now is the time to really go out and kind of seize these opportunities. Or if you want to kind of consider transition to a role that's maybe not technical in nature, but still has a direct impact on the business. Being a product manager who has knowledge about how machine learning works is a huge competitive advantage in this market. So at this intersection of product management and data science, with some of these trends we're seeing around generative AI and stuff, a lot of opportunities have opened up. Victor was telling me about how most of the audience here are graduate students, so this might be an area for you to really double click on and see if you're interested in going forward. Cool. So we spoke about how most products today will start to incorporate AI and machine learning in some format. So that kind of brings us to the question, what are the key phases and steps to build products that incorporate machine learning in some format? And you really zoom out from a technical level, we think of them as ranking problems or classification problems or regression problems, but ultimately all of this drives some customer experience at the end. So how do we think about building these products and what's the framework? The way that I kind of think about it is I divide it into 3 phases, and with each phase having subsequent steps. So let's make this framework a bit more actionable by talking through phases first, and then we can dive deep into the steps. So phase 1, as I call it, is being able to conceptualize. And this phase starts by thinking about, hey, what are we trying to achieve here? What problem are we trying to solve? And then as you end this phase, you have an answer to how you're going to solve the problem, actually leveraging machine learning, and you know what success looks like. So conceptualizing is really the starting phase of how products are built. Generally in the industry, the PM takes a lead on kind of defining some of these phases or defining the foundations of the product. But good PMs also tend to bring their own teams along, and that includes technical teams and data science teams too. So conceptualize, very formative phases, PM generally takes the lead. Again, we'll talk about subsequent steps in each of this once we lay out this framework. So the second phase is develop. A lot of times data science teams are taking the lead in these phases and they're bringing the PM along. And what essentially means is like, when you're going to really, at the start of the develop phase, you're going to ask yourself, how are we going to build a model? So that's the question you start off with. And towards the end of the develop phase, you have an answer to that question. And more importantly, you have a model ready that you think is really ready to be tested in the hands of customers. So development phase is when a lot of these technical nitty-gritties, finding the model, feature selection stuff happens. And at a high level, it's mostly driven by data science teams, by bringing the product manager along. The third phase is the launch phase, where now we're thinking about how do we hand over these products to the hands of our customers. Again, any product that's being built has an end user out there. So how are we thinking about releasing the model or the ML-based product we have into the hand of customers? So the question you're asking at the start is, how do I get this into the hand of my customers? And towards the end, you would probably have done that. In addition, you would have your customers really adopting the product and being successful at using it. So at a high level, conceptualize, develop, and launch are the three phases that we can go through. One thing I really want to call out though is you can lay it on a chart and make it really sequential that says like, hey, conceptualizing the first thing, developing is the second thing, launching is the third thing. But usually there's a lot of concentric cycles involved when you're trying to figure out stuff. And sometimes you go from the develop phase back to the conceptualize phase based on whatever you're learning. So think of it as a high level framework, but actually in the industry, there's a lot of like concentric circles and action going on in terms of moving between. So let's dive deeper into the first phase, which is around conceptualizing. And I mentioned that at this phase, we start by thinking, what are we trying to achieve? And at the end of this phase, we have an answer to how we can use ML and what success looks like. So under the conceptualize phase, first thing, and this is critical for any software product, service, or algorithm that we build, is to really identify what the customer problem is. It's important to remember that anything that we build at a company essentially has an end user who's using it. Now, this end user can be a customer who pays for your product, or it could be someone internal at the company who's actually using tools that you're building. So ultimately, whatever you're building has to solve a problem for that person. And that's the purpose of like using this technology and building all the advancements that we want to do. So once you identify the customer problem, you try to create key metrics, and these are usually product/business metrics. And they serve two purposes basically. One is, are we solving the customer problem in the right way? How do we know that we're solving the customer problem? And then usually good metrics tie back into the business too, in terms of like, are we generating business outcomes? The advantage of having these key metrics defined in the conceptualized phase is basically that it stands to serve as a prioritization for the team. Like usually what happens is if you're working at a tech company, there's like 10 different things that your team can be doing. But how do you pick the few ones that are actually important, both to customers and businesses, is an area that you want to dive on. And the key metrics almost serves as a guiding light for you to get there. So once you define the key metrics, you want to build a strong hypothesis. The hypothesis would essentially be able to tell you like, hey, how do I solve the customer problem by using ML in a way that moves my key metrics in the right direction? So essentially what happened in this phase is you started with the customer problem, and now you have an answer to how ML can fit to solve that customer problem. That's the conceptualized phase. Development phase is where a lot of magic happens, and this is where data science teams are heavily involved. The development phase has two steps. The first one is being able to look at the data that you have. If you have enough data, you need more data, or you probably have changed the kind of data types that you're using. A lot of this work is led by the data scientists on the team. And it's a constant interaction between product managers in terms of, hey, here's what we're seeing in the data, here's what we're observing, this is what we additionally need to do. So this is the first step in terms of like taking a look at the data that you have, because it's critical to building the models that you want to build. And after this, you head into the model development phase. And this is where you're thinking about the models that you're selecting, the features that you're using, how are you using the combination of these features. This part is heavily being driven by data science teams too, and it's like the core of what they're building at different tech companies. I think one of the things that, as I was going through this presentation, one of the concepts that I wanted to introduce was offline experimentation, which is basically around how do you now, once you think you have a model that's actually good, how are you actually benchmarking that model? How are you selecting among 10 different models that you have in terms of being able to say like, hey, this is the one we have the highest confidence about? And offline experimentation is basically a way to do that, where you're measuring the performance of your model against the data that you have currently. This is not testing it with live customers. This is data that you already have access to. The way that I kind of like to think about it is, let's say you're at Amazon, the homepage can have like 10 items that you can list. And there's probably, like you want to change the ranking algo that displays these 10 items. And there's probably like 6 of them with past purchases. And if you have 10 model candidates, like which of these models is essentially able to predict those 6 among the 10 slots on the homepage that you have? And how do you measure this using the past data that you have? So this concept of model development and offline experimentation is very iterative from a sense that based on what you see in the offline experimentation, you're going back to the model development and trying to create some of the criteria that you have. The metrics at the end of the offline experimentation phase are mostly your ML-related metrics. So example for a classification problem might be area under the curve. So what happens here is the data scientist is working, iterating, and tuning the models. And then they come back to the PM and say like, hey, for example, we have found a model that we think has a really high offline AUC, and we think this is ready to be put in the hands of customers. So what happened at this phase is we started with the question of how do I build a model, having a model which we think is ready to be tested in the hands of customers. And another call out in terms of why offline experimentation is important is it's usually costly to test something in the hands of customers because one, there is like impact in terms of time, how long you need to get results. And 2 is there's also impact in customer experience. So you want to really make sure that whatever you happens in the automation phase is also the steps. And they're like, hey, you need like a set of sample data around like implementation. So what are the results you're generating for this user? Almost like a heuristic, make sure that we're putting the right things. So that brings us to the launch phase, where at the start of the launch phase, we spoke about thinking about how that this product is actively being used and adopted by your customers. So among launch phases, products are never rolled out from like 0 to 100 to all of your customers. You start slowly by doing an A/B test, which is basically 50% of your users see something that's coming from the old ML model or product or algorithm. 50% of them see the results coming from the new algorithm. And based on the impact to your key metrics that you defined during the conceptualized phase, you're able to make a decision on do you want to roll this out into production or not. And once you see the A/B test working, you're usually saying like, hey, yes, we know this is working, so let's roll it out to all customers. So that's an overall framework as you think about building ML products. Again, 3 phases: conceptualize, develop, and launch. Subsequent steps under each phase. There's one area that I want to iterate again. It's basically that it never happens sequentially. Like sometimes you go into the development phase and you're like, hey, the data set is not right, or we probably cannot even acquire new data. At that time, you're going to just scrap some of the efforts that you have. Sometimes you launch an A/B test and you realize that the model is not performing as well as it did offline. At that point, you're like, there's no point in kind of 100% rolling these out to users. In my career, there were times when like we actually rolled out a model by an A/B test, showed like 3 or 4% increase in business metrics. And then we were still like, let's roll it back because if you actually deploy this in production, the cost of maintaining the model is more than the business impact that we're seeing. So a lot of times these decisions go a bit like in concentric circles in where you're trying to triage and figure out like what's the next best thing that you can do both from a customer standpoint and a business standpoint. For a lot of these decisions, generally in tech industries, PMs take an active lead in terms of thinking through the trade-off and criteria here and keep the data science team informed of how these decisions are trending or how the business is. Now, this serves as a high-level framework. So let's see this framework in action at 2 of the companies that I work for and walk through a couple of case studies. I just pause here. Any questions from the group around the framework itself or anything that I can help clarify?
Sure. I got one for you. So are you saying that like data science teams in your experience don't typically interact in the conceptualized phase as much?
They actually do. But there's always like a driver for the effort in the team that comes along. Usually PMs tend to do it, but then good PMs also bring the teams along, and the data scientists also want to be involved in the process. We get to this point a bit towards the end when we talk about best practices between collaboration, and there's going to be some interesting dynamics in play. But short answer is data science teams are definitely involved in this phase, and good teams come along in the process of discovery.
And you might touch on this later. If you do, feel free to keep moving on. But following up with that, would you say that data scientists tend to generate more of their own leads, or that most of their leads come from PMs?
It's a collaborative process, and I've seen influence happen either ways. We'll talk about it. What's the end? Great questions. Thanks for asking.
Yeah, and then when you get questions from the audience like this, if you could just repeat the question so that the Zoom land also gets to hear what he was asking about. So the initial question was asking about conceptualization and whether data scientists are part of this or not. And then your answer was they are a part of it.
Yep.
And then the next question was?
Next question was more around who drives the work. It's a collaborative process. Victor, we might have a thing with Zoom going on. I see it just stay constant.
Yeah, it's because of the fact that we have two different screens going on, this one and this one. So if we mirror them, I can get rid of that. But if we don't, then it's gonna. Sorry about that.
Cool. Glad we got that. Awesome. So let's talk about how products are built in the industry. The first example I have is from Upwork, which is my friend employer. How many of you have heard about Upwork? Oh, lovely. So Upwork's a freelancer marketplace where clients across the globe, across all sizes, ranging from one-person startups to like Fortune 500 companies, can come in and hire freelancer and agency talent across the globe. And what happens here is Upwork provides the tools to discover these freelancers, hire them, and pay them. And Upwork provides the freelancers an opportunity to apply for jobs, bid for services, to get hired and get paid. And we have a whole ecosystem of tools around messaging, collaboration, payments, and project management integrated. Essentially, work gets done on Upwork. Point to note is a lot of work that Upwork supports is basically white-collar work, things like development and IT, like want to hire data scientists or sales and marketing professionals, customer support professionals. So a lot of these work is white-collar work, which is typically needs a device to be worked on, but Upwork's the world's largest freelancing platform. Last year, about $4 billion worth of work across these categories was done on Upwork. And one fun fact that might be relevant to this audience is, as we think about the generative AI space and some of the work that's happening in the space, a lot of these companies or famous names that we hear out in the news actually use Upwork to train and build the models that they have. So that speaks to a testament of the quality of talent available on the platform. By the way, a plug here, we're actually hiring. So if you're interested in analyst roles, product-related roles, feel free to check out upwork.com/careers. Wanted to hear that, right? Yeah, been there. So let's talk about a case study where we think about showcasing relevant freelancer projects to first-time clients. I know that's a lot captured in one sentence, so let's dive a bit deeper into the case study. So the specific product we're going to talk about is Project Catalog in Upwork. What essentially Project Catalog means is it's a product that was launched in early 2021. And then what happens here is freelancers can package their work into projects and list it for clients at a flat rate. An example of a project can be, I will design a logo for you for $50. Or it could be, I will build a website for you for $200. So talent package their work, present it to clients. And what you're seeing here, the client-facing experience, which is a browse and buy experience, similar to what you've seen on other e-commerce sites like Amazon or Temu, it seems really popular today. And then you essentially click into a project, hit checkout. And then because this is a browse and buy experience, ranking is a critical component of all browse and buy experiences. Upwork just launched this in 2021, so we're talking about some of the use cases back then. The way that people usually found this product out, because it was a new product, was because Upwork was running a lot of ads on Google. So essentially, if somebody typed, I need a logo on Google, they would essentially see an ad that says like Project Catalog, and then they would land on the page that you see on your right. So we spoke about a three-step framework: conceptualize, develop, and launch. Let's start with the conceptualized phase and talk about the customer problem here. So new clients want to see the best projects available so they know at the right place. Take an example of somebody who's coming from Google onto Upwork. They're probably seeing Upwork for the first time. How do they know that Upwork has the right kind of talent or problems? And what are the metrics that we care about is one, from a customer standpoint, if they're finding the projects relevant, they're purchasing the projects, so visit to purchase rate. Because Upwork was spending money on acquiring these users, it had to make sense from a business standpoint, so Upwork generate revenue. So it's one of those examples where like this metric is solving a customer need, and it's also like doing it in a way that's incremental to the business. So what's the hypothesis? If we use past purchase data and ranking, then we increase the likelihood of clients purchasing projects because having a past purchase is a good indicator. And we're not talking about client level data because we're talking about new clients. So there's no opportunity to do personalization. We're talking about project level data from the project that's been purchased in the past. So that kind of segments away into the develop phase where one of my data scientists who was working on it came back to me and said, hey, because this is a new product, past purchase data is not enough. And this is to say that Upwork operates out of 9 categories. There's about 100 subcategories. So how do you get a data set that aggregates all of them, especially for a new product? So my data scientist partner found that data we had was not enough. And their recommendation was, let's also use click data to increase coverage. Purchase is always a bottom of funnel action where users are getting to the purchase at the end, but we had higher amount of clicks because you actually have to click into a product to purchase. The other thing they flagged was also the fact that the data set had a lot of positional bias in the sense of a lot of projects which were purchased in the past were basically projects that were displayed in the first 2 rows. I think this is a common problem across most e-commerce sites. And this was a problem that Upwork had at that point. So we went into the model development phase, plus offline experimentation, because I kind of spoke about how integrated they are. And a lot of the magic here is being worked on by data science teams. So the way that they kind of implemented the model was to be able to predict the probability of a project being clicked or purchased among the list of items because it was a ranking problem. And then because they were identifying positional bias, they also considered position weighted data while training the model. And then based on offline AUC, the team thought this was definitely an implement of the current model. Again, during the model development plus experimentation phase, the data science teams are working their magic and actually figuring out the stuff and making sure they're iterating the right way. And towards the end of this phase, they generated a list of categories and a list of projects that were being displayed by the new algorithm. And as a product manager, I had to take a look and see if it generally made sense for you. So because we got to a point of high AUC, the teams decided that this was right and we were ready to do an A/B test. So we did roll this out as an A/B test, and 50% of new visitors to that page saw projects generated by an older algo, and 50% with the new algo where we had impression to click and impression to purchase features involved. And this hit the ball out of the park. We saw a double-digit growth in visit to purchase rate, which was our key metric. And this was one of the largest wins for the team. Part of it was because this was a new product. There was a lot of scope for optimization. But part of it was also because ML was done the right way, in a way that captured customer problems and generated an outcome for business. And this was because this experiment was such a clear winner, we released it to all customers. Like I said, this is one of those happy paths where we identified a problem, did the key metrics, figured out how ML can be used. Then we segmented into the model development phase. Realized that we had to add additional data sets, so that expanded the hypothesis that we had. But as it came to the launch phase, it's the clear winner and hence the launch. So another example is from my time at Glassdoor. How many of you have heard about Glassdoor? Yeah, so Glassdoor's I don't feel like it's so relevant to job searching today, and if you're almost like looking for jobs and trying to search jobs, it's a must-have tool. So at Glassdoor, for those who have not used the product, is basically a platform for job seekers to go and look about information about companies, so this is salaries, interviews, reviews, and all that related data. And job seekers can also apply to jobs. And you have employers on the other side who usually post these jobs. And sometimes these jobs are sponsored, which is like the employer is telling you that they will pay you for every candidate who applies to the job. Then employers can run ads to attract candidates too. There's a two-sided marketplace from that instance, where you have the job seekers on one side and the employers. Upwork's a two-sided marketplace too, where you have like clients on the one side and job seekers or freelancers on the other side. And just to note, if you're ever considering a role in the tech industry, I generally think talent marketplaces or work marketplaces are good companies to be in. There's so much good that you do in terms of the products that you build, in terms of the features that you do, and how it impacts actual customer lives. So if folks were considering certain opportunities, I'd like to consider some of these companies going forward. So at Glassdoor, we talk about a recommendation problem where we want to recommend relevant jobs to job seekers. And then if you actually sign up to Glassdoor, kind of look up a few jobs and read about a few companies, you immediately start getting job recommendations, and Glassdoor kind of lists out that these recommendations are based on your profile data and activity data. Ultimately, we are using user-provided data plus activity data to generate recommendations. And in order to generate these recommendations, one of the key components is basically what is the user's preferred job title. Say, for example, somebody in this room, if they worked as a data scientist before, they would probably be looking for senior data scientist jobs. Somebody has worked as a product manager before, they're probably looking at senior product manager jobs. So knowing the preferred job title is relevant to being able to generate recommendations for this user. So again, segmenting into how we thought of this as a machine learning problem, in the conceptualized phase, the customer problem was that job seekers want to be able to be notified of jobs that are relevant to them. Ultimately, whether you go onto Glassdoor or whether you're kind of passively job searching, you want to see an email of jobs. Job seekers would love to know about jobs that are relevant for their skill sets and in the roles that they're interested in. In terms of key metrics, it's basically, are these users applying to jobs? So job applies per user. This is also an incremental business metric because we spoke about how Glassdoor monetizes of the number of job applies it drives to employers. So what's the hypothesis here? And this is where teams are asking the question of how does ML play a role? If we infer a user's preferred job title using ML based on their past interactions and surface recommendations, then we increase the likelihood of them applying to jobs because these jobs are more relevant and we are able to accurately assess their preferences. So our hypothesis was that if you're able to identify the user's preferred job title based on the activity, we could start generating recommendations based on this, and the user would be more likely to apply to the jobs that we recommend to them. So then kind of the data science team started working on this magic, and to your point, identifying the problem statement was highly collaborative here, and it was one of our data scientist ideas that, hey, this is a problem statement we can go after. And then during the data availability phase, one thing that we noticed was users had multiple job title interactions, like somebody who's looking for software engineer roles, the title on the user profile would read software intern because it's most likely the current title. They would apply for a senior software engineer role because sometimes in the job world, candidates, we see that overestimate their capabilities and are always optimistic, but that doesn't happen on the employer side. And then they're applying for a job title that reads like hiring rockstar software engineer or hiring 10x software engineer. And they have a job alert, which is basically like a user created job alert for a software dev role. And they're clicking on a completely different title. So what the data science team found is essentially that, hey, there's a lot of signal loss going on because some of these titles are so disparate and the users clicking and interacting with all of them. And the other thing we found out was like, job clicks and job apply data had high data coverage. So more users had this data and also like more volumes of this data. And some of this data was even from like the job seekers activity a few years ago. So these were a couple of things that the team found while reviewing the data availability. And that got us into the model development plus offline experimentation phase. Again, this is where the data science teams are working their magic and mostly partnering with the product managers on some of the outputs that they're seeing. And the way they said this problem is essentially, can we predict the probability of the user clicking a job title for every pair of user and job title? And then we spoke about how there was a lot of signal loss, so they decided to normalize the data, which essentially means to say that while you're training your model, software dev and software developer mean the same thing. And then because we spoke about a lot of click and apply data, they decided to test different time windows from a sense that if you're looking for a job or you clicked on a job 3 years ago, that would most likely not reflect what you want to do next in your career because 3 years have passed. So we did a lot of this experimentation and finally got to a point of high offline AUC via our offline experimentation. And ultimately, some of the model output look like what you see on your right is basically for different job titles, either user inputted or inferred. What are the weights that we see, and a combination of this finally decided what is the job title that the user is ultimately interested in. Any guesses on which job title here had the highest weight? Someone said salary? Okay. Good guess. Any other ideas?
Maybe click title. If I had to guess, just like the thing that drags you in.
Close second.
Okay.
I'll give the answer. The highest was job alert because this is users explicitly stating, yeah, I'm interested in this job. Now send me an email. Any idea on what the lowest weight here was?
Profile, yeah.
That's right. Profile, because profile is always indicative of what they're doing currently, not what they want to do next. So ultimately, like the data science team worked a lot of its magic in this space and shared the results of this data. I looked at a few interactions, looked at some of the training data sets that we had. It all made sense, and we ultimately decided to put this as an A/B test. But if you think about an A/B test, one of the things was, well, like, where do we want to deploy these recommendations? And here, the goal for the team at any tech company is to actually run fast. So if you think you have something working, how can you actually put impact and make sure you're rolling this out to all customers? We decided to test via email because our email traffic was higher and send out recommendation emails to these different job seekers. 50% of the time this was driven by the old algo, and 50% of the time it was driven by the new algo that we had. And this was a big win too. Java price per user was up by X%, X confidential, obviously. And then once we kind of figured this out, we were like, hey, how do we get this goodness to the hands of all of our customers? So we ended up deploying the new preferred job title model-based recommendations across desktop and mobile. And then ultimately, I think one of the other questions that you're asking is, yes, we had this win. Now, how can we double down on it? So the data science team went back to the table and came out with 2 clear recommendations in terms of additional things that we can be doing. And one of them was to iterate to improve the coverage of users who had a preferred job title. And the other one was around including additional data points per user that we had not considered earlier. So this was also a big win for the team. And I think one of the takeaways here was, in terms of the problem statement here, we spoke about how PMs usually lead in the process, but this was an area where data science had identified that, hey, we can actually use ML to generate more relevant job seeker recommendations. So as you think about processes and as you go to the industry, it's always collaborative in nature, with each of these teams influencing the other. So we spoke about that. We have about a couple of minutes, and I did want to kind of stress upon the slide. If you're either working in product management or data science, some of these tips might be relevant to you. Is what are the best practices in terms of how these teams collaborate? First is realizing that conversations are a two-way street. As much as product managers can influence data science teams in terms of the product vision and roadmap, throughout my experience, I've seen data scientists also influence product management teams in terms of, hey, here are the things that we should be doing, or here's what the data is telling us, or here's what we can actually do to improve some of the models that we have. It's a highly collaborative partnership. There has to be a lot of respect between both of these parties, and ultimately that leads to both good customer outcomes and good business outcomes. The second one is align really very early on the customer problem that you're trying to solve and be realistic. One thing, if you've noticed, is in both the examples we spoke about, there was a heuristic model that existed in production. Ultimately, we were using ML for the first time to improve these models. And that doesn't, I mean, because we saw successes, that doesn't mean the decision to use a heuristic model was wrong. It probably was the quickest way to do things back then. So as you think about incorporating technologies like AI and ML, ask yourself the question, is this the fastest way for us to get value to the customer? And any technology that you use should be like a follow-up to that. You should never be leading with the technology in it. The third thing is want to be a bit process light as you collaborate with different data science teams. The traditional tech industry uses the agile development processes. And in my experience, I have not always seen it work for data science. The reason is like data science is a process, especially during the develop phase, is highly probabilistic. It's not something like, hey, let's build the software. This is the requirement, and this is how the user will interact with the button. It's more probabilistic in terms of, hey, here's the data that we feed to the model. Here's the feature engineering that we can do, and here's the results that we see. So typically, you want to be a bit process light when partnering with data science teams and kind of give them the autonomy to do that. But again, as you really think about it, the questions that you're asking is, how do we reduce uncertainty and kind of get to quick prototypes while actually building about these solutions? So being process light is one thing that I saw that worked in the two roles that I've been about. 4 is really be open to killing things or killing ideas when they're not working. I stressed upon this a bit before, but sometimes when you're in the develop phase, you realize that, hey, this is not working the way that we intended to do, or like ML is not being able to solve this problem in an effective way. Could be data set coverage, could be the kind of choices in terms of the modeling, could be the fact that some business conditional criteria has changed. And it could also happen at the launch phase when an A/B test might not go as expected, and there could be underlying reasons for it. In all of these cases, you ideally want to debug some of this and understand why machine learning is not performing the way it is supposed to. But ultimately, as a team, you have to be open to the fact that there are things that you do in the industry that will not work out. When things are not working out, how do you kill that and move on to solve the next big challenge? But this is more relevant for probabilistic fields like ML, because we spoke about how it was not like a clear-cut yes or a no answer. And the 5th one is basically share the champagne with the team. A lot of times, building products in a tech company, ML or otherwise, is highly collaborative in nature. Like, are you highlighting the wins of each of your team members and putting them up, and then giving them credit in forums where you have to? That does have a lot of ripple effects on how well teams run and the kind of products that they build. And especially for the PM data science collaboration, which is going to be like super important in terms of how the tech industry shapes up from this point on. I think sharing credit and making sure that people are getting the visibility that they deserve is going to be a huge part that you might want to take in your next role or next career going forward. So those are the few learnings that I've had from the industry that I wanted to share with this group. I hope it has been helpful. We can take any quick Q&A if folks have questions.
Thank you very much. Now we'll open the floor first to our in-person questions, and then I will go ahead and check Zoom for any questions that we have there as well.
Oh, I didn't realize we had a mic here. That's very provided. Sounds like cool.
Oh, thank you for the talk. And my question was around the metrics to evaluate. You mentioned that maybe you will use metrics to evaluate this model was serving, or you have to kill it. Your example, your metrics is conversion rate, right? In first case study. So I think it's really hard to kind of come up with a single number to determine the model. For example, why don't we choose conversion rate times value per transaction? It could be more precisely representing this. But if we kind of dig in like this, it's really hard to come up with a simple metrics like that. So how your team come up with a clear part?
And so if I understand your question correctly, you're talking about metrics that we determine in the conceptualized phase more around business metrics. Are you talking about ML model specific metrics?
Business.
Business, yeah. So the question's around like how do we determine what the right metric is? It's to be honest, there's this whole science that talks about how do you set key results in business. In terms of how you set business metrics, is you want it to be like measurable. actionable? Can the team actually move this metric or have this metric in its control? Then 3 years, like, is it really predictive of user value? Or is it right? So it's never, there's always trade-offs involved in terms of determining like, hey, there's a couple of things that we can be doing, and this might be 2 different metrics. Usually how it functions is teams are really looking to prioritize a few key ones. That kind of hits these criteria, and it could be as simple as like, hey, in like the first half of this year, our goal is to help users convert. In which case you're thinking about a conversion related metric that can measure it. And the second part of your year, that goal might be, hey, now we've got users to convert. How do we get them to their second purchase? So a metric could be like percentage of users going on to the second purchase. A lot of times it comes down to what the objective for the business is and what the business is trying to achieve, and what are the key customer problems they've identified in that conceptualized phase. And there are always trade-offs involved. And one thing that teams that I have been a part of is doing is we never measure one single metric. We treat one single metric as a North Star. But there's always secondary metrics that we've already tracked. For example, in the e-commerce example that I gave, conversion rate was the primary metric. But 2 is we were also measuring average order value, because you don't want 100 users to buy and they're purchasing like $5 projects. Whereas like typically 50 users can buy and they can be purchasing $1,000, way different revenue numbers. So while we took visit to purchase rate, we had average order value as a guardrail metric, but the team was cooking. So the primary metric and the guardrail metric would be an important like way to think about how do you prioritize between them.
Typically, kind of how people, maybe data science or machine learning engineer, be involved in such kind of pieces from, because I think maybe there will be a kind of CEO problem or product manager.
Yeah, I think that's a great question too. In my experience, it always comes down to the individual sometimes. I work with data science partners who were super actively involved in the modeling part, and that's what they wanted to be doing. And there were certain data scientists who actually came up and were like, why are we thinking about it this way? Why don't we think about it a different way? Like, it's highly dependent on the individual. I think, again, one thing that I kind of recommend is as teams go through the conceptualized phase, is everybody clear on the customer problem and the key metric, and are kind of working towards it. So you might not play an active role in defining it, but are you clear around why this is important? And that's how that shared context between teams is happening. Great questions. Thank you.
Okay, so we have another in person, and then we'll switch to Zoom.
So for both your experiments, you mentioned that you had like this 50-50 split for your A/B testing. I'm kind of curious, like how you kind of arrived at 50-50, or even like if you could disclose how big your samples were for these particular experiments.
Yeah, good question again. It's been a while, so I don't really know the samples. And it's also a function of like, what do you need to do to get to statistical significance? That's a trade-off. The way that I always think about it is like, you can run a 50-50, or you can run like a 33-33-33. And there were instances in my career where like the data science team was strongly passionate about 2 models. Here are 2 leading candidates. And we did run a 3-cell test where we did 33, 33, and 33. Ultimately, from a business perspective, you're looking at what is the time to learn, what's the time to trade off, and how much confidence do we have in each of these solutions. So that trade-off will help you determine, are you doing an A/B test, or are you doing an ABC kind of test? I'm trying to think of a few examples in the past, but so for the Upwork related experience that I spoke about, because it was a new product and we were actually paying to drive traffic, having 3 cells were being costlier because now we are dividing paid traffic across 3 different experiences. So we needed to have like a higher degree of confidence if you want to go 3-cell test, which is why we did a 2-cell test. That was a classic A/B test. So those are some trade-off criteria for you to think about as you think about, okay, do we want to test 2 variants, or do we want to 3 variants? Time, confidence, and cost. You'll have to triage between these three factors and make it.
And then as a quick follow-up, in your experience, I guess it would probably depend on the company, but is there traditionally a lot of time for like data scientists to pick up their own leads, or is it really like, like here's your thing, here's your next thing, here's your next thing?
Yeah, that's a great question too. So just to make sure I interpret you right, like, do data scientists have their own bandwidth to determine the projects that they?
Yeah.
Yeah. Right now it comes to company culture.
Yeah.
There's a lot of companies which are now experimenting something called 10% times. And they're like, hey, do what you want in the 10% and show it back. I'm not sure how going into this tech trend is going to hold.
Yeah.
Yeah, like you said, it's highly company specific. But I don't think good teams are usually budgeting for a healthy time of experimenting. Seen that for teams that I've been a part of the past, where like 25% is on time. The other way to approach it is like, can we do like quarterly hub hackathons where teams have 2 weeks to think of solutions that they think. So company specific, good teams branch their own time. I think the other thing that I've noticed is like really good data scientists who deliver results are really trusted and manage their own workloads and things like that. So it kind of comes down to like some of the individuals on expertise and credibility. This person has delivered this amazing project in the past. They could probably be doing their own thing. Sometimes like I've had engineering counterparts and machine learning counterparts and say like, this person is probably outfitted for any product task from this point in time. And I was like completely okay with it. I know that this person be working on something super company going forward. So it's a trade-off. Good data scientists are like respected in terms of how they prioritize their time, and then good companies always see time for all of their teams to have these 10% projects that can turn out to be cool. Thank you for the question again.
Okay, so our first question from Zoom is, how did you resolve your positional bias problem that you had earlier presented to us?
Yeah, I wish I had my data science partner with me to answer that question, because that starts to go into delve into questions that are highly technical in nature. I believe it was, again, I don't know, maybe misquoting some of my teammates, but I believe it was just accounting for the fact that if a project was in the top few rows, there was a higher probability of it being purchased. So we applied a common discounting factor to make sure that we're not kind of giving that as a signal in the training data. So the discounting factor kind of normalized for it. This is what was shown. But again, I think at this point, this is where this is like pure data science question in terms of how it happened. But I'm hopeful that it gives some directional sense of how.
Thank you. And another question that might be a little bit data sciencey, but they were wondering, how do you communicate metrics like AUC to PMs, and how do you translate that to performance improvements?
Yeah, that's a great question again. My answer is don't try to talk your PM about these unless they do machine learning. I think tactically, one advice that I've always found is like give PMs samples from your data experiments and say, hey, here's the user ID, and here's the results that we're seeing in terms of here's the relevant recommendations we're generating. If you start to make it a bit more clear to them in terms of examples, that's when they get it. Like, here's what's going on and here's what's the model doing. So lead with real examples of outcomes and real data sets that's guiding it. And then honestly, I think we're going to see a change in the industry when PMs start to also know what are metrics like AUC and stuff, because we spoke about how most products will start incorporating data science or ML in some shape and format. So I think all I got to say is like maybe data scientists should expect the PMs to learn better. And
Thank you very much. Thank you very much. Let's give a round of applause. For those of you online, please be sure to join our meetup group for the University of San Francisco Data Science Seminar Series. Next week, our speaker will be David Andrzejewski, who will be talking about security log data with models. Well, there, thank you, everyone.
Awesome. Yeah.
Okay.
Yeah. Okay.